Welcome to Sustainably Speaking. I'm Joshua Baca. On today's show, we'll be talking about innovation and leadership. Throughout history, people have focused their sense of purpose and innovative spirit to enhance the quality of life. No exception to this drive for excellence is Eastman Chemical, headquartered in Kingsport, Tennessee. Eastman's innovative products help make life safer, easier, and better for people all over the world. And they emphasize sustainability every step of the way, from transportation to building and construction to medical equipment. Eastman and its employees continue to challenge convention and collaborate to achieve the improbable, including a big project announced earlier this year in its hometown. Joining us today is the visionary leader of this innovative company, Mark Costa, board chair and CEO of Eastman. Mark has directly overseen the launch of Eastman's two new advanced recycling technologies aimed at helping to solve global waste and address climate change. Mark, thank you so much for taking some time to speak with us today. I know personally I have been very excited about this conversation, the work that Eastman is doing, and really your bio and your leadership is also something that has really caught my eye. And so why don't we start right there? On this podcast, we're talking about issues that surround sustainability and circularity. And we're hearing a lot about the plastic waste crisis and the concept of a circular economy. So maybe a two-part question. Tell us about Eastman and tell us a little bit about what you're doing.
Sure. First of all, it's great to be here and talk to you, Joshua. It's an exciting time where I think Eastman and the chemical industry has another opportunity to lead with a lot of innovations to meet some real challenges we face in the world. And there's no doubt that the plastic waste crisis is a significant one. When you think about 300 million tons of plastic produced a year, only 12% of it being recycled, that's something we have to address. And we also, and it's very important to note this, that whatever solutions we come up with, they also have to address climate at the same time, right? We have to make our impact on climate better. We have to address the waste crisis. And I think Eastman's really well positioned to be a leader in delivering innovative solutions to this dual challenge. Eastman has a long history. For those of you who are not familiar with it, we were part of Kodak for a long time and then spun off as our own separate public company in 1994. We're a special materials company with a very diverse portfolio of about 14,000 people, sell in 100 countries around the world. And we're headquartered in Kingsport, Tennessee, which is an incredibly beautiful part of the Appalachian Mountains near North Carolina and Virginia. And that beauty of that area, reminds us every day about how we need to protect the environment, and something that we take quite seriously. It's a company of a really diverse set of materials, as I said, but we're mainly durable focused. So a lot of people in this discussion around the circular economy are, heavily in single-use plastics. So we're really thinking of ourselves as a technology sort of solution provider to some of these challenges. But the circular economy has become a huge focus for us in the last 2 years, really 2 to 3 years, where we see a significant opportunity for us to lead and prove that these solutions are economic, scalable, and can really both get plastic waste out of the environment and reduce carbon footprint at the same time. And I know that's really going to be the focus of the podcast, but this isn't something new for us, right? We're not saying, hey, environmental sustainability is important now as it's become trendy. We've been doing this for the last decade.
That's great, Mark. And what a great story. I bet you a lot of our readers, or a lot of our listeners, probably don't realize that you were one time part of Kodak. So that's a great story there, and great story about your innovation and the work you're doing. And so maybe I could take off on that point. You talked a lot about innovation and sustainability. The American Chemistry Council has set some ambitious goals. By 2040, 100% of our plastic packaging will be reused, recycled, or recover. And we support those three principles of reduce, reuse, and recycle. Does Eastman agree with those three are the critical ones and the principles you guys follow as well?
Yeah, so when it comes to circular economy, we completely agree that the 3 R's are incredibly important. And a lot of our product innovation sort of serves all three elements of this, right? So when you can reduce what you're using, for sure you should do that. A lot of what we go into in durables is about reduce and reuse, right? So if you buy, hydration bottles, the sports bottles out there, which is where our Triton goes, that allows you to replace single-use plastic water bottles. So we have a lot of growth that goes into a variety of those kind of products. Or we're in the SodaStream product, for example, for doing, soft drinks, as opposed to buying those kind of products. So we think there's a lot of application out there. And And we do believe recycling is part of it. So there are applications out there, packaging that's going to be necessary, like hydration, like food preservation, delivering product to people's homes, with all the online services. So reduce, reuse is great, but there's still going to be materials out there that we need to recycle. And we think we've got a set of technologies that are really going to serve three core principles, Joshua. One, get the waste out of the environment. And with our technologies, we can do it in an infinite loop. Second, lower our carbon footprint by replacing fossil fuels, with a process that's more efficient than the fossil fuel process we have now. And third, no compromise in performance and quality. The brands and consumers, want to improve the environment, but they also, like to hold on to the quality of the products that they have today. And we shouldn't have to make that trade-off. And we think we can do that.
And Mark, on the issue that we deal with at the forefront of many stakeholders' minds is the plastic waste crisis. Some advocates have advocated for simply banning the use of plastic. Might argue that that might be short-sighted based upon many of the innovations that Eastman in particular is leading. But why not just ban plastics? And is that line of thinking reasonable or unreasonable?
It's easy to sort of fit, ban plastic on a bumper sticker and say, yeah, we've solved the problem. We got rid of plastic. But it really, skips over a lot of really important criteria we have to think about. First of all, let's just be clear. A lot of plastic goes into durable products that are essential for the environmental goals that everyone has, right? So EVs, electric vehicles are incredibly dependent on plastic to lightweight the car, to enable the functionality that it has. They play an essential role in electronic vehicles. They play an essential role in many appliances, electronics, for lightweighting, for durability. So there's a lot of places in durable products that they're the only way we can actually achieve carbon neutrality in 2050, which, by the way, Eastman's, committed to doing an aggressive goal of, getting our carbon emissions down 35% by 2030. So we're very committed to carbon footprint reduction, but it's not just what we do in our plant. It's also the products that we make that enable everyone else downstream of us to achieve significant improvements. And a lot of that is in durable products where a lot of our innovation is focused. And as I said earlier, packaging is going to be necessary, right? There's a lot of places where there's not safe drinking water. There's a lot of meat and vegetables that are preserved with plastic wrap that's essential to serve a growing population that has these needs. And there's no solution, that would readily replace them in many of these applications. So when you think about plastic, if you want to ban it, then you got to say to what, right? It's easy to say to ban something, but then you have to follow the conversation. It's like, okay, what's the material that you intend to use that's going to be better, both on the waste issue and making sure it doesn't end up in landfill, but also on climate. And that's where the challenge shows up. The reason plastic has dominated so many applications over the decades is because it's better on the climate front. It takes a lot less carbon or energy to make plastic than other materials that are available today. And it's much lighter, so you also save a huge amount of money and emissions on transportation. So it is a superior product for climate. The issue is we got to recycle it. There's no doubt that if we don't recycle it, then you've got a challenge relative to these other materials. But on a carbon footprint basis, there's a lot of studies out there. Just to give you one example, in PET, for bottles, right? An essential part of, how people stay hydrated around the world is the availability of water in these containers. If you ban PET, then you'd have to go to another material, right? The ones that are available today are glass or aluminum or, multi-layer paper. And the vast majority of studies that have been done out there to look at the life cycle footprint of these alternative materials show that glass is on average about 120% worse carbon footprint than PET. It takes a phenomenal amount of energy to make glass, and you have to use a lot of it because the strength to weight ratio is pretty bad. Aluminum, same thing. A lot of people think aluminum is better than PET. It's not. These studies show that it's 50% greater global warming potential than PET with aluminum because, again, phenomenal amount of energy used to make it the first time. And even though it's recycled at 70% and PET is a lot lower, that 50% includes the higher recycling rate of aluminum versus where we are today. When we improve recycling for PET, that 50% story is going to get even better. And then multi-layer paper, same issue, fails a recycling test. Once you've put enough coatings or waxes or other things on the paper to hold water, it's no longer recyclable and it's going to end up in landfill. And with all that coating, it's not going to biodegrade either. So every conversation we have has to include, if we don't want something, then what's your alternative that's going to be better for not just waste, but the climate? And that's what we're focused on, is a solution that does both at the same time. And I think There's a lot of applications out there after the first two R's, which are really important, of reduce and reuse, where packaging is necessary. Let's make sure we pick material that's best for the environment on all dimensions.
And Mark, I want to pick up there and get to a little bit heart of the conversation on the issue of recycling. And maybe we could take this in two pieces. There's mechanical recycling and advanced recycling. Eastman is obviously a leader in the advanced recycling space. But I think we all generally agree, and as you've outlined in our principles, recycling is a must. What about mechanical recycling? What is the role for mechanical recycling today?
So, as everyone knows, mechanical recycling has been out there for a really long time, and it has a very good carbon footprint. So it does meet the two challenges I was talking about: get the waste out and at a lower carbon footprint. But it has three limitations that have to be understood in what role it can play in the short and long term for addressing the overall plastic waste challenge. There's about, as I said, about 300 million tons of plastic waste out there. Only about 40 to 45 million tons of that actually gets collected today. And it's mostly PET and high density polyethylene. Of that, 11 million tons gets discarded for contamination. 22 million of it goes into non sort of bottle to bottle applications, fiber, strapping, sort of lower quality applications because it's just not usable. So then you only end up with about 9 to 10 million tons going bottle to bottle, which is really the goal. Because if you're not replacing the bottles with recycled content, then you're still pulling a lot of fossil fuels to make all the bottles that you can't use mechanical for, right? So that doesn't really create a solution because of these limitations for some of these applications that are out there. The second thing is there's a compromise in product quality and performance, especially when you start taking mechanical recycle to a high percentage of the product. You start to get color issues and sort of performance issues on how the polymer works in these applications. So there's going to be limitations, even if they found some way to use more of it, or you're going to have to compromise on how the product looks and performs, especially how it looks on the shelf. And then the third and most significant is it's not an infinite solution. Aluminum is an infinite solution in how it can be recycled. So is advanced recycling. And we'll talk more about that, I think, later. But it's infinite, where you can continue to loop it. Mechanical starts to degrade over time. So after 5 to 7 laps in the recycling loop, it's going to start having degradation problems and not be usable. So it is an incredibly important part of the solution, but advanced recycling complements it in important ways that we can get into to make sure we're addressing all of the waste problems. So you do mechanical wherever you can, then have advanced recycling, use all the polymer that can't be mechanical recycled to solve the total problem and provide an infinite life.
So, Mark, last week I was speaking to a stakeholder about the issue of advanced recycling, and I articulated that advanced recycling is out of the pilot stage and into the commercial stage, and there's a huge demand for recycled plastic and recycled products, and that technology is not static and it continues to evolve. And despite that, some critics have called advanced recycling a pipe dream. Clearly, Eastman doesn't see it that way and is making some significant investments, both in innovation and technology. Can you tell us a little bit about your approach to advanced recycling and some of those investments and innovation you guys are making?
So first of all, as I said earlier, solving this challenge, the dual challenge of waste out of the environment and reusing all this carbon that's just being, wasted in landfill or worse, getting in the environment, and doing it at a lower carbon footprint is essential, right? For us at Eastman, we've been solving significant challenges for over 100 years with our focus on improving the quality of life. And this is just another very significant one where we're really excited and I think well positioned to be a leader in proving out these technologies. In fact, we already know it works. We're not at the pilot stage anymore, the theory stage. We've got 2 technologies that are operating now. They're scalable, they're economically viable, and they are for sure good for the environment and climate. And so we can talk a little bit about both of these technologies that we're doing and sort of demonstrating feasibility. The first is a polyester renewal technology, which is methanolysis. And that is the one that centers around PET and other polyester products like textiles or carpet. So we take all those feedstocks. To be clear, it's not just bottle. We can take textiles, we can take carpet, and we can use advanced recycling to turn them back into products that are similar to the ones where they came from. So with polyester, we start by using a bit of methanol and some energy to unzip the polyester back into the monomers, the building blocks, if you will. Then it goes through some purification, and then we can make the identical polymers on the same polymer lines today that we make from fossil fuels. So the products, once they're purified, are identical to the current products, which makes it really easy for the brands to adopt because there's no changes in process, mold conditions, performance testing. They can just move to these new products with recycled content. So adoption is really easy and incredibly important. And this is infinite, as I said earlier. So you unzip it and you can just do this over and over again. We've also made sure that this technology is good for the environment and has a lower carbon footprint and does not have any toxic waste as byproducts. So in the analysis we've done, which shows that we can be about a 20 to 30% lower carbon footprint in making these monomers. And that's a pretty significant improvement as we displace fossil fuels and petrochemicals with this feedstock. And that's assuming that the energy we use right now is coming from fossil fuels. We have a number of projects to replace all that with green energy, and that would significantly improve the carbon footprint beyond that 20 to 30%. And importantly, transparency and third-party verification for all this is incredibly important to us, given all this sort of greenwashing that I think is going on out there. And so we've had all of this verified by CE Delft, which is, leading authority on how to do LCAs. So, we're trying to make sure that this is credible, third-party verified, and good for the environment, as well as solving the waste problem. And right now we're running a semi-work scale plant, and we're constructing a $250 million methanolysis plant that'll be online at the end of 22 as we sort of fully scale up. So this is really exciting, a lot of progress going on. Excited to see this plant that we're building right here in Kingsport. The second technology is the carbon renewal technology, which is reforming. So Eastman has been making biopolymers for 100 years. The cellulose acetate went to Kodak film, if you want to go back in our history, is a biopolymer. And it's made from about 60% wood pulp that we get from certified, sustainably grown forests. And the other 40% is acetic anhydride, which is a derivative of vinegar, basically. Today, it's made from fossil fuels, and we're going to replace that with recycled content. I'd also note that it is certified biodegradable. So when it becomes a microfiber or a microplastic that could get in the ocean, waterways or land, it's certified. And again, third-party certified by UV Austria as okay biodegradable and okay for compost in those environments. So biopolymer replacing the anhydride, which I'll explain in a moment, with recycled content and biodegradable. So really great offer for the marketplace. And what we're doing here on the recycled content side is replacing the fossil fuels with waste plastic and making the acetic anhydride. And so today we have a gasification process that uses coal as feedstock to make the carbon monoxide and hydrogen to make that acetic anhydride. We can replace that with waste plastic. And because we're replacing, the coal with a much higher carbon value product, which is plastic, right? Because coal's more like dirt. It's 20 to 50% better carbon footprint to make those feedstocks to then go on into the anhydride and then making the biopolymer. So very compelling, same kind of situation, also third-party verified by Delft. So two technologies, all both scalable. The great thing about the CRT is it's directly scalable, don't need a plant, we're just changing feedstocks. It's also important to note in both these technologies, none of this recycled content is being used for fuel or energy, right? This is material to material recycling at very high conversion rates.
That's great, Mark. And your innovation is obviously the leader in the space, and we continue to love to hear more of the story. And so let's continue to build on that a little bit. Massive global companies have made a lot of public commitments over the last few years. And one key element here to the success of advanced recycling is getting brands to support these innovative technologies. Your innovation that clearly you're so passionate about, your workers are so passionate about. How do we solve the challenge to help them meet these commitments and educate their consumers on these solutions? What engagement have you seen, and how are you making progress with your brands and your customers?
It's incredibly exciting to see the kind of engagement we're getting from the brands. As you mentioned, there's a lot of leading brands out there, almost all of them in the consumer goods world, who've made very aggressive goals about recycled content by 2025 and by 2030. And it's great to see their commitment about improving the environment. The challenge that they have is they've done the same analysis we have that I was talking about earlier, and they realize that there isn't remotely enough recycling capability in these markets to meet their commitments collectively. And they've also done the analysis at the mechanical versus advanced recycling level and have recognized that mechanical recycling is not going to be remotely sufficient to meet their goals, and that advanced recycling is going to have to be a key part of this solution. Again, they need a long-term solution. They don't want to give up product quality, So they need that infinite, no compromise on quality issue in the products that they're buying, which we can provide with advanced recycling. And of course, they want to do this at a lower carbon footprint and make sure that we're solving the total plastic waste problem, not just a slice of it that, meets the criteria I spoke about earlier with mechanical. So for them, this is essential to sort of, maintaining their brand position on the shelf, addressing the dual goals of reducing carbon footprint and getting waste out of the environment. And we've seen really good engagement from a lot of iconic leaders as we've moved forward and scaled up these two solutions. So in polyester, we've seen some great adoption on the consumer durable side, like Nalgene and Camelback with their reusable water bottles, Williams-Sonoma with consumer drinkware, Tupperware for their storage containers, Lander for iPhone cases. And this is just the beginning. There's a long list of customers we're working for, but these are the first that have adopted. Cosmetic packaging, which is a place where we do play a lot with some of our products, which is, a longer life than single-use plastic, but still packaging. And so Estee Lauder has adopted our technologies with their recent announcement to apply to a number of their packages and brands. LVMH has also recently adopted and engaged with us to using our polymers there, as well as a leading Korean brand named Clio. And then on the biopolymer side, we're seeing tremendous engagement in the textiles market for the biopolymers, because it's not just single-use plastic that's a waste problem. Textiles is, and fashion, fast fashion in particular, is a huge challenge for waste and landfill. And so we're providing a circular solution where we can take textiles back, recycle them in our CRT technology back into cellulosic fibers that are biodegradable if they become a microfiber. So great solution there. Eyewear. We've got two key converters that make most of the luxury sunglasses out there called Thaleos and Marchand that are adopting it. So really good engagement where they see the need for this. They understand it. They have very sophisticated sustainability departments doing all the same analysis we are, making sure it's all third-party verified and feeling good about what we're doing.
Clearly, you're very proud of the work your company is doing. And I think we can all agree with this, that technology continues to evolve. It's not static, and it's created tremendous new opportunities and tremendous breakthroughs. Why is Eastman unique when it comes to the success of advanced recycling?
I think we have a number of advantages, especially in the technologies we're in around polyester and cellulosics, where we've been the leader in R&D on these different technologies since they existed and invented a huge array of products off of that. So from a technology point of view and an operational point of view, I think, we've had a lot of advantages. Our strategy, as I said earlier, is upscaling. We're taking these waste products and upscale them into durable products. We will also, do some of this into packaging, but that's not really our core focus in what we're doing at this point. We have a lot of experience in recycling, something I didn't mention earlier, but Kodak deployed and used this methanolysis technology over 3 decades ago for recycling X-ray film that they were taking back from the marketplace. And then they realized they could use municipal waste. So we have a long history of using methanolysis. So this is not a new startup technology that we have to pilot to figure out how to build it. We've done this before. In fact, 10 years ago, I had this project as something I wanted to build, this methanolysis project back in 2010-11 timeframe. But we couldn't get customers engaged at that time to support building it and paying the modest premiums that we need to sort of fund the investments. So it's not new to us. And we have a lot of operating expertise and insight on how to run this technology. So I think that's important. Also, we're at significant scale, and the integration and assets we have, especially in Kingsport, to get started with this are a huge competitive advantage for us, where we have the ability to construct capital, operate it, and start it up and solve problems that you invariably run into. So I think that gives us a huge advantage, especially against a lot of the startups out there. And so we've got aggressive goals. We want to get to 250 million pounds of waste by 25 and 500 million pounds of waste being processed by 2030 for our internal needs. Now, what's important to mention is that's just us for our internal needs. We have tremendous engagement by brands, countries, and other partners who want to build plants around the world beyond what we're doing for our specialty sort of strategy, where we would build plants to make PET for all the packaging needs that are out there that I was talking about earlier. So we're really excited about that. And so we're working with all these different companies to see how we can construct and build these plants. But it's very scalable, to build a number of these plants in Europe, US, Asia, to really address this challenge. And we're working hard with these different partners to do that beyond those internal goals I mentioned a moment ago. So really exciting. And to answer that question, yes, it's scalable and yes, it's economic. And you can actually do this in a way that doesn't compromise on product quality on the shelf, as well as better carbon footprint.
I think it's clear, Mark, that the market fundamentals that define advanced recycling have significantly changed over the years and will continue to evolve. And, hats off to you on your complex and ambitious challenge and goals that you have set up. 250 million pounds of waste out of the environment and 500 million pounds of waste out of the environment, I think is something that we would all agree on as a positive thing. Within the division and within ACC, we spend a lot of time talking about partnerships. And we like to think that integrated solutions on circularity and sustainability drive partnership. And you mentioned a lot about the need for partnerships here. An issue like this that is so big and needs a lot of people rowing in the same direction to deliver solutions, what do you feel are the critical areas that are needed for collaboration?
So there's a need for a phenomenal amount of collaboration. We recognize, that we could be a leader in demonstrating what's possible with this technology and scaling it up to some degree. But, the large amount of polymer that's out there requires a lot of our peers to be scaling up technologies, especially in spaces we're not in, like polyolefins. But it's beyond just the industry we live in. There's a lot of collaboration we need on policy, on infrastructure, with the brands, and even at the incentive level, at the consumer level and the brand level, to sort of drive the entire closing of this loop. So we need smart policies that are going to provide incentives, mandates, support infrastructure investments that are necessary. Lots of conversations around there. And our hope and desire is that we can work with people writing policy to help them with the science and the economics to make sure that the solutions we drive towards are really going to solve the problem. As I said earlier, if we ban plastic, you may solve one problem on plastic waste. You're just going to create another problem, which is, going to materials that are going to be worse for climate. Well, that's not a solution, right? That's not a good way to go, because we shouldn't be trading off in these goals. We should be accomplishing them together. And we also, need to partner, at the more local level, not just on the policy, but on the infrastructure side about how the recycling waste management, gets optimized and used effectively to supply the feedstocks that we need. It's odd that there's so much waste out there, but the structure to get it back to recycling is challenged. And so we need solutions on that front. And we also, of course, need to work with our customers, our brands, who've been great partners with us so far, very engaged in how to solve these problems. And there's a lot of education to consumers, around the real facts about what's out there and what needs to be done. There's a lot of misinformation, and we need to get consumers to understand what their role can be, because they play a key part in closing the loop.
And with that, Mark, I want to thank you so much for your time today. Most importantly, I want to thank you for your leadership and the work you and your team are doing to help us achieve some really big goals. Your ambitions and your knowledge of these issues are greatly appreciated, and we look forward to speaking to you again sometime soon.
Thanks, Joshua. I really appreciate it. It's a great opportunity to talk to all of you. We are extremely excited, but we also really am looking forward to and asking for, parties out there to reach out, connect with us where they see opportunity, because it is a huge collaboration effort to solve this problem. I think it's an incredibly exciting time to be part of this industry and innovating a whole nother generation of solutions to solve these, world challenges. And we're really looking forward to doing it.
Thank you for listening to this episode of Sustainably Speaking. And special thanks to our guest, Mark Costa. If you have any thoughts to share from today's episode, consider sharing it with your friends and colleagues or including it in a rating and review. You can also reach out to us directly at sustainablyspeaking@plasticmakers.org. We'll be back in your podcast feeds on July 19th with our next episode about our low carbon future. Together, we can change our perspective, our behavior, and the world. I look forward to Sustainably Speaking again soon.